Our planet Earth has a long and exciting history. It's full of amazing changes. Some changes are slow, like mountains growing over millions of years, but some are very sudden and violent. These sudden events can change everything on Earth. Two of the most powerful forces are asteroid impacts and volcanic eruptions. Imagine a giant rock from space, bigger than a mountain, crashing into Earth. Now imagine thousands of volcanoes erupting at the same time, covering the land with lava and filling the air with poisonous gas. These events have happened before, and they will happen again. These events are not just destructive, they are also a part of Earth's story. They've shaped the planet and life itself. Understanding these events helps us learn about our past and prepare for our future. Asteroids are like giant rocks that zoom around our sun. Most asteroids live in a big ring between Mars and Jupiter. But sometimes an asteroid's path changes and sends it hurtling toward Earth. When an asteroid enters our atmosphere, it becomes a fiery meteor. Small meteors burn up completely before reaching the ground. But if the asteroid is big enough, look out. It can crash into Earth with incredible force. This is called an asteroid impact. One famous asteroid impact happened 66 million years ago. It's called the Chicxulub impact, and it caused the KPG extinction event. This event wiped out the dinosaurs and many other forms of life. The asteroid that hit Earth 66 million years ago was huge, about 6 miles wide. It slammed into the Yucatan Peninsula in Mexico with unimaginable force. The impact unleashed a chain reaction of disasters that changed the planet forever. First came the fire. The impact generated so much heat that it ignited massive wildfires across the globe. Then came the darkness. Dust and debris from the impact and fires blocked out the sun, plunging the Earth into a long, dark and cold winter. The impact also released poisonous gases into the atmosphere, creating acid rain that poisoned the water and soil. These devastating effects combined to create the KPG extinction event, wiping out about 75% of all plant and animal species on Earth, including the dinosaurs. Volcanoes are openings in the Earth's crust where immense pressure builds up over time, forcing molten rock and gases to the surface. When they erupt, they release lava, ash, and gases in a dramatic display of Earth's inner power. A single eruption can reshape landscapes, destroy ecosystems, and alter weather patterns for years. But now, imagine not just one, but thousands of volcanoes erupting continuously across a vast region. This phenomenon is known as a large igneous province eruption, an event so massive it can cover entire continents in lava. These eruptions can persist for hundreds of thousands, even millions of years, releasing unimaginable volumes of lava and gas. Around 252 million years ago, during the late Permian period, Earth faced one such cataclysmic event. Known as the Permian Extinction or the Great Dying, it was the most devastating mass extinction in our planet's history. Life on Earth was nearly wiped out. Ecosystems collapsed and biodiversity plummeted to unprecedented lows. Scientists believe this extinction was triggered by a massive large igneous province eruption in what is now Siberia, forming the Siberian Traps. Over time, these eruptions blanketed the land in lava and released vast amounts of carbon dioxide and methane. These greenhouse gases trapped heat in the atmosphere, causing global temperatures to soar and ocean chemistry to shift dramatically. The oceans became acidic and oxygen-deprived, turning once thriving marine habitats into dead zones. As a result, nearly 90% of all marine species vanished, including trilobites and many types of coral. On land, about 70% of vertebrate species perished, leaving behind a world eerily quiet and empty. Volcanoes might seem, destructive at first glance, but they're actually a natural and vital part of our planet. These fiery giants are more than just dramatic explosions and rivers of lava. They're part of Earth's deep, dynamic system that's been shaping the surface for billions of years. They play a key role in shaping Earth's geology and even its atmosphere. From forming new landmasses to recycling elements between the Earth's crust and atmosphere, volcanoes are like the planet's pressure valves, releasing built-up energy from deep within. That said, during something called a large igneous province eruption, or a LEPI eruption, their power can really turn devastating. These aren't your average eruptions. They can last for hundreds of thousands of years and release unimaginable volumes of lava and gas. Volcanic eruptions release huge amounts of greenhouse gases, like carbon dioxide, into the atmosphere. In a lip event, the sheer scale of emissions can overwhelm natural climate systems. And this, well, it can trigger a runaway greenhouse effect, leading to really rapid global warming. Temperatures can spike dramatically, altering ecosystems and pushing species to extinction. But interestingly, volcanoes can also have the opposite effect. They can cool the planet. It all depends on what they release and how much of it reaches the upper atmosphere. The ash and sulfur dioxide they eject into the atmosphere can block sunlight, which leads to global cooling. This cooling can last for months or even years, depending on the scale of the eruption. On top of that, volcanoes release chemicals that can make ocean waters more acidic. When lava and gases interact with seawater, they create chemical reactions that alter the ocean's pH balance. And that's bad news for marine life. Coral reefs, which are already sensitive to temperature and acidity, can bleach and die off. Fish and other marine species struggle to survive in these altered conditions. This kind of thing actually happened during the Permian Extinction, and it contributed to the massive die-off in the oceans. It was one of the most severe extinction events in Earth's history, and volcanic activity played a major role in tipping the balance. So, could asteroid impacts and volcanic eruptions actually work together to cause even more widespread extinctions? Well, some scientists believe so. The idea is that the impact of a large asteroid could actually trigger massive volcanic eruptions on the opposite side of the planet. Kinda wild, right? Remember the KPG extinction event? Some researchers think that the Chicxulub impact might have set off massive volcanic eruptions in India. Those are known as the Deccan traps. These eruptions released huge amounts of lava and gases into the atmosphere, and that might have made the extinction event even more severe. The combination of an asteroid impact and massive volcanic eruptions, yeah, it's a terrifying thought. But it's also a powerful reminder of nature's incredible force and why it's so important that we understand these events. So, the big question, can it happen again? Could Earth face another cataclysmic event like a massive asteroid impact or a supervolcanic eruption? The good news is that these kinds of disasters are incredibly rare. We're talking about events that occur on timescales of millions of years. Most of us will never witness anything like them in our lifetimes. I mean, they don't happen every day, or even every million years. But just because they're rare doesn't mean they're impossible. And here's the sobering truth. They can happen again. Earth's history is full of dramatic events that reshaped the planet and its life. That's why scientists are constantly scanning the skies for potentially hazardous asteroids. It's not just science fiction, it's a real part of planetary defense. Using powerful telescopes and advanced computer models, they track thousands of near-Earth objects, calculating their orbits and predicting future paths. If one looks like it might come too close, we want to know, early. In fact, in 2022, NASA launched the DART mission, the Double Asteroid Redirection Test. It was the first real-world test of our ability to deflect an asteroid. The idea? Crash a spacecraft into a small asteroid and see if we can nudge it off course, and it worked, proving that we might have a fighting chance if we ever spot a real threat. That success gave scientists and engineers hope that we're not entirely helpless in the face of cosmic threats. But it's not just space we're watching, we're also keeping a close eye on the ground. Earth itself can be just as dangerous. Scientists monitor volcanoes all around the world using seismographs, gas sensors, and satellite imagery to detect early warning signs of eruptions. Changes in temperature, gas emissions, or even small earthquakes can all signal that something big might be brewing beneath the surface. Now, while we can't really stop an asteroid impact or a volcanic eruption from happening, we can definitely prepare for them. Emergency drills, evacuation plans, and early warning systems can save lives. So, can it happen again? Yes. But thanks to science, technology, and global cooperation, we're more ready than ever before. Understanding past extinction events? Yeah, that helps us get ready for what might come in the future. By studying things like the KPG impact and the Permian Extinction, scientists learn about the possible consequences of these events and how we might reduce their impact. For example, researchers are working on ways to deflect asteroids, build early warning systems for volcanic eruptions, and even develop technologies to remove greenhouse gases from the atmosphere. And here's the thing, international cooperation is absolutely crucial. Sharing data and resources lets scientists all over the world work together to tackle these massive global threats. The Earth has faced a lot of challenges over its long history. Asteroid impacts and volcanic eruptions, yeah, those are just two of the powerful forces that have shaped our planet. Sure, these events can be incredibly destructive, but they also remind us of the amazing power and resilience of life on Earth. Today we're dealing with new challenges like climate change, pollution, and habitat loss. But by learning from the past, understanding the present, and working together, we can build a safer and more sustainable future for all life on this planet. It's really up to us now. We have a responsibility to protect Earth, and make sure it stays a vibrant, thriving home for generations to come.